Scooter is one of the most common two-wheelers popular in many parts of the world. They are typically equipped with an automatic transmission system. This transmission system is known as continuously variable transmission, or CVT. The basic principle of a pulley-based CVT can be demonstrated by using this simple setup. It has a driver pulley and a driven pulley with variable diameters. A V-belt with constant length runs between these two pulleys. High RPM is obtained by increasing the diameter of the driver pulley and decreasing the diameter of the driven pulley. High torque is obtained by doing the opposite. This system allows us to achieve infinite number of drive ratios between the minimum and maximum limits. It is not possible to simply change the diameters of solid pulleys as shown in this demonstration, so engineers develop certain mechanisms to obtain similar mechanical characteristics. A variator assembly is used for this purpose. Here, the pulley is made up of two conical plates. One of them is fixed to the input shaft, and the other is free to slide along its axis. A V-belt runs between these plates. The rear side also has two conical plates between which the belt runs. One of these plates is fixed to the shaft, while the other can slide sideways. A compression spring forces the sliding plate to stay close to the other plate. This forces the belt to stay at the highest diameter of this pulley. In the driver pulley, the axial stiffness of the belt pushes the sliding cone farthest apart. This causes the driver pulley to have minimum diameter. This is the condition of high torque, low RPM. To obtain high RPM, the diameter of the driver pulley decreases and that of the driven pulley increases. Let's understand how this is achieved in the actual scooter CVT. The sliding conical plate of the driver pulley has a set of rollers or sliders as shown here. When the engine is at low RPM, the rollers are held near the center of the pulley. As the engine gains speed, centrifugal force causes rollers to move outwards along a curved surface. These rollers push against the ramp plate. Since the ramp plate is fixed, the sliding conical plate is forced towards the other plate. Let's see the diameter change in slow motion. This is similar to the condition of high RPM, low torque as we observed in the demonstration. This transmission system includes a centrifugal clutch assembly. The inner portion consists of weighted arms held in place by extension springs. These arms are connected to the pulley. The clutch housing is connected to the output gear. When sufficient speed is reached, the centrifugal force causes the arms to swing outward, and the friction pads engage with the clutch housing. The clutch housing transfers power to the rear wheel through a gear train.